Hey guys, this is Einar. I hope that you're doing great today, and welcome to this tutorial where we're going to be talking about bivariate table construction. Now, what does bivariate mean? Well, bivariate data is data that has two variables. So I'm going to exemplify this for you because I think that's the easiest way to understand it. Let's say we have a sample of 16 respondents, 16 people that have answered some kind of survey that we sent out. And one of the questions on this survey was, what gender do you consider yourself to have? So if they're coded as 0, they're male. If they're coded as 1, they're female. We take our answers, we code them, and then we place them in a data set like this. So this first person here is coded as 1, so that's a female. This second person here is coded as 0, so that's a male. So it goes on male, female, 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 male, 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 etc. So these are our 16 respondents that have answered the survey, and they have answered this question. Then the next question on the survey is, on a scale from 0 to 5, how well do you think our current Prime Minister is doing her job? Okay, so then we have pretty much the same procedure. This person answered a 1, so this person thinks on a scale from 0 to 5, the current Prime Minister is doing a 1 well job, which is pretty low, 1 considering it's from 0 to 5, so this person does not think the Prime Minister is doing her job very well. So this goes up all the way to 5. This is our second variable, and you might notice that I've aligned them here together, and that's because this person here who answered female also answered a 1 on this second question. And it goes on. So this person here who's a male answered that they think that the Prime Minister is doing a 2 on her job as being a Prime Minister, and so on. So each of these observations is a pair, and they're coupled to a respondent. So while our variables may be separate, they're still based on the same respondent. So this value here in x and this value here in y is linked to the same person. So that's what we're talking about bivariate data. It's data that has more than one variable. In fact, it has two variables. Okay, so let's say I want to describe my bivariate data in a bivariate frequency table. Well, it's going to look something like this. What I have here is I have one variable listed down here, I have one variable listed here. And these have their values listed in cells. So my health can be low or high in my example here, or my income can be low and high. So the observations are then placed in these 4 cells depending on what category they belong. The people in this cell, for example, well, they have low income and high health, so they end up in this cell. People in this cell, meanwhile, well, they have high income and high health, so they end up in this cell. And then we sum them all up in these cells here, and the total number of observations I have then will be 197, which is located in this cell. You might notice that, well, I can't place any frequencies here in between the cells or in between these cells. That I can only use discrete variables. So I have to use strictly separated categories in my variables. And you might think that, well, income is not a discrete variable. Income is a continuous variable. I could have 0 kroner income. I can have 42,000 kroner income. I can have 21,533 kroner as my income. So it's not a discrete variable. Why am I listing it here as low and high? Well, I may have my own theoretical reasons, but I'm going to tell you now how you can do this. What you need to do is you need to truncate it in order to use it in a bivariate frequency table such as this one. So truncating. Well, if we think of these lines here, these black lines as income, the income variables, you have 0 income here, and you have, say, 30,000 in income over here. I have a number of different ways I can split this data into different pieces, so I could use it in a bivariate frequency table. I could use my max value, so I find my max value in my data. Let's say it's 30,000 kroner, for example. The highest paid person in my data set has 30,000 kroner in wage. I divide that by 2, so I split the data at the point where 15,000 kroner is. So everybody with lower income than 15,000 kroner, they are said to have a low income. Everybody with a higher income than 15,000 are said to have a high income. I could also use the median to do this if I want the middlemost observation instead of dividing it just by the value in half. So I use my median and I say, well, okay, the middlemost observation is here, so this is where I'm at 50% into my data set. So everyone above here, well, they get classified as having a high income, even if there are more observations on this side than this side. The same thing goes for arithmetic mean, just a different way of calculating the centrality. It's based on slightly different characteristics, but there's a tutorial about that, so look at that if you don't know what the arithmetic mean is. Or I could use some kind of theoretical idea. Maybe I'm saying, well, this top here, that's the 1%, so they have a high income, and the rest of us, 99%, we have a low income. It all depends on how you want to use your variable when you're going to use it in your bivariate frequency table. There are also rules for where you're going to place your variables. If you're going to correlate them somehow, for example, you might say that, well, I think that health is dependent on income. Well, then I should place health in this part of the frequency table. And if I say income affects health, it doesn't go the other way. Income affects health, well, then I place that on the top here in my frequency table. So horizontally, independent variables. Vertically dependent variables. That's just a rule you need to know when you're going to create these frequency tables, because we're going to use them for correlation later. So that's why you have to be very careful when you're placing your variables. So in our example, we had income here, we had health, and we had vitamin. We have our frequencies here, and you might notice that, as I said, we have a strict separation here between the cells, which illustrates, I'm going to emphasize this. This means that we have a discrete data when the cells are strictly separated from each other, and you have then the frequencies represented in the form of numbers in each cell. So that's usually how a table works. Each cell then will have a characteristic. People in this cell, they will have two low values for both variables. So they have low health in our previous example and a low income, so they get minus minus. People in this cell here, well, they have a high health and high income, so they get plus plus. That's the people in this cell. And you can probably extrapolate from what I just said what these two cells mean. So when you talk about these kind of cells, you can also talk about quadrants. Now, what do I mean by quadrants? Well, quad, that comes from a Latin word of quattro, meaning four. So it basically means you're dividing your frequency table into four pieces. So this is going to be a negative piece, and this is going to be a positive one, this is going to be a negative piece, and this is going to be a positive one, because here we had two negatives, and two negatives make a positive, and here we have two positives, they also make a positive, and here we have one negative, one positive, that's negative, we have one positive, one negative, that make a negative. So that's basically how quadrants work. If we have a continuous variable, what we would do then is we would remove the separators between the cells. That's our first part. We still have quadrants. You have to remember that. We can still divide our cell into divide our area into four parts. But for interval and ratio scale variables, you remove these lines to emphasize that you can be placed in between here somewhere. It's not like you have 1 point here, 1 point there, 1 point there, 1 point there, where all our frequencies are placed. And then you also start talking about the x-axis and the y-axis, because now we have to figure out a way of how to represent the observations. Before we could use numbers, but now since we don't have these cell separators anymore, we have to, represent our data somehow. So what we do is we take our continuous values on our x-axis here. So if this was income, we would have 0 there, and we'd move up here to a really high income, and vice versa for health. We say we have some kind of index. So this is like you have 0 heart attacks a year, and here you have loads of them. I know it's a really bad example, but you know what I mean. For continuous variables. And what you do then is instead of using numbers, you represent your observations by dots that can be placed in between, they can be placed in the middle, anywhere along your data area that you're working with. But remember, we still have quadrants, so the observations located in this area here, well, they're going to contribute with positive correlation to future correlation measures that you might use. Now, you don't have to know that right now, but there are other separate tutorials you can watch to understand it. But what a scatter plot basically says is, well, if you take a look at this observation here, you move all the way down here, you see it has a high value in x. You take a look at this observation again, you move over here to the y-axis, and you see it also has a high value on the y-axis. And meanwhile, then you can take a look at this observation, which has a low value in x, and it also has a low value in y. And as I said, these were positive quadrants, and if you take a look at these dots, you can see that they seem to have an upward slope. So I would say that if I was to draw a line here, it would be a positive correlation. You'll learn more about that later, so don't worry about that for now. But if you were going to represent this data, you would say, well, it is a positive relationship. Meanwhile, if it was the other direction, it would be a negative one. So basically, that's what you need to know about bivariate frequency tables and scatter plots for now. I hope to see you in the future tutorials. Have a really great time with them, and I hope to see you later. Have a really great day, guys. Bye-bye.